Okay, so here's the deal. This is what we're doing today. You guys, we're looking at day 2 of PreCalc 4.5. We're going to have the day 2 coverage. We're skipping over day 1. We'll do day 1 tomorrow because day 2 really revolves around us reminding ourselves about sine and cosine. Okay? So everything I'm about to do, I want you to remember it's about sine cosine graphing. And then we're going to do the one step that makes it secant and cosecant, okay? And remember, secant is 1 over cosine, and cosecant is 1 over sine, and that's how we're going to relate these. So the first thing I want you to know about the characteristics of your graph, if we can get this to actually work the way it's supposed to, and it's not working, all of a sudden it's not liking anything I'm doing, okay? So the characteristics of the secant function are inferred from the fact that it is a reciprocal of the cosine function. So when we do a reciprocal, if I knew the cosine was 0, what's the reciprocal value? What do we know about the reciprocal of 0? It's undefined, right? It should, and we'll actually see an asymptote on this graph. Okay, so everything we were about to do, we're going to do as if we are going to graph cosine. Okay, see if I got this set up, and let's do this before I even continue. Okay, so I'm going to put in my key points. So I've got pi over 2, pi, 3 pi over 2, 2 pi. Hey guys, I really need you to be quiet during this. If you want to talk, go ahead and take it out someplace else. I have better things to do than compete against that and for you not to pay attention and waste my time later. Okay, thanks. Okay, I got negative pi over 2, negative pi, and negative 3 pi over 2. Going back. And remember, these are my 5 key points. If I look at a general cosine, if I'm talking about cosine, remember cosine has a period of 2 pi. Okay, my 2 pi period, 2 pi is broken up into 4 equal parts. So I got 2 pi divided by 4. That's where my pi over 2 comes from. So that's where I get 0, pi over 2, pi, 3 pi over 2, and 2 pi, and 5 pi over 2. Okay? Are there any questions about those as I'm going out? Okay? Now, generally when I do my cosine, remember, this is all about cosine. I'm going to actually sketch out what cosine would look like. I'm going to start at my high. Okay, so I'm going to be here. I'm here. I'm down here because this is positive 1. This is my negative 1. Okay, and I'm back to the axis. I'm back up top. I'm back down. And I reverse it. Coming back here. I'm down. I'm up. Now, because I'm working with secant, when I get to zeros, cosine zeros, I will have asymptotes. So, at 0, at 0, at 0, at 0, and at 0, I'll have vertical asymptotes. Does it make sense why? Because those are where my cosines were 0, and the reciprocal of 0 is d and e. It does not exist. Okay, all right. Now, remember I have my highs and my lows left, okay, because all the axis values are now asymptotes. So the difference of graphing today, instead of taking my cosine, which would look like this kind of, my cosine would take on this look, right? I do the reciprocal of those values. Okay, what's a reciprocal of a value that's incredibly small? It's really, really large. Okay, when I'm actually graphing my secant, this is what happens. This is my secant value being graphed off my cosine function graph. It is the reciprocal of the values provided. Okay, well, the reciprocal of 1 is 1. But as I head closer and closer to my asymptotes, okay, and we'll just talk about down here between 0 and pi over 2. My y value, when it's really close to pi over 2, is something very small just above the axis. But I would do the reciprocal, it tends to infinity. So it will flip up. And that is graphing your secant. The black lines is the secant graph. Okay, are there any questions regarding? Now let's talk about some of our values of that secant graph. Okay, I'll give you time to write those down. Write them down, and then we'll just talk about those. We're getting that done. I have an announcement. We have conferences this week on Thursday. This is the day that I'm taping this. We're looking at 3/1, March 1st, 2018 is our conference night. I will not be in attendance. I will be at the state meet down at the University of Minnesota. So on that night, I will have a time and space issue. At that time, here at Elk River High School, I'll be required to be in a different space. Time and space conflict right there. Okay, so just know that email will come out tonight talking to your parents about that, and you guys will receive that very same email. So that's what that will be about. Okay, make sure that you're really concerned about getting your assignments done. Next Friday, a week from this Friday, is your Chapter 4 Part B test. Okay, and I think it'd be as early as Thursday next week, but I think I'm going to push it around to Friday. I just got to look at the timing. Okay, so keep in mind you're on top of those things and you know what's going on with stuff. Now, remember, period. And one of the other reasons why I'm doing this is the period's going to change when we do tangent and cotangent. I'm starting with day 2 because I'm grouping all the periods that are 2 pi big together. Okay, the period of a secant is 2 pi. Okay, as I'm looking through the vertical asymptotes, wherever the cosine of x is going to be 0. All right, and we have horizontal asymptotes. There isn't. It is a bounded. It's an unbounded, I should say. It's an unbounded function when we're talking about secant. Cosine was bounded. Okay. This is talking about the domains. Okay. The asymptotes aren't part of the domain. Okay. We're defining it that way. And every time we go around and talk about doing our n pi, every time I go half pi, I have another asymptote pi later. I have another asymptote, another pi later as we go through this. My range from negative infinity to -1 and from 1 to infinity, and that makes sense when I'm looking at my graph working for secant. It's an even function because cosine's an even function. So please keep in mind, this is kind of a big deal when I'm working with my b value. I won't have to be too concerned with a negative b value working with secant because it does the same thing that happens with cosine. Okay, and consequently, when we deal with cosecant, the same thing that happens with the sine negative value comes out front. For the cosecant, it will also come out front. Okay, local extrema, I got minimum of 1 at x equal 2n pi and maximum of -1 at x equal pi plus 2n pi. Remember, every time that repeats in its regular function forever, as we look that over. It's not bounded above or below, but remember the cosine is bounded, but the reciprocal of that is not. Now, with that information going, we've got secant graphed. Let's talk about what happens with cosecant. You're going to do exactly the same thing. Everything is pretended like you're going to graph sine. Okay? So we're going to pretend like we're going to go graph sine and get after that. Characteristics of the cosecant functions are inferred from the fact that it is the reciprocal of the sine function. Okay, I'm going to freeze this because it helps with my graphing, because moving this thing around is kind of an annoyance. Okay, so same idea. I got my key points. I'm going to be graphing roughly. Remember, cosecant goes from 0 to 2 pi for its period. So I have a period of 2 pi. I'm going to split that 2 pi into 4 equal parts that are pi over 2 apart. So I've got pi over 2, pi, 3 pi over 2, 2 pi, and 5 pi over 2. And I'm going to go back, negative pi over 2, pi, and negative 3 pi over 2. Now, part of this graphing is for me to be able to see where my sine is 0. So I'm just going to pretend I'm graphing sine. Okay, so remember, sine had a max of 1, a min of negative 1. Okay, sine always started on the axis. Okay, Sahala. So it starts on the axis, it goes high, it goes to the axis, it goes low, back to the axis, it goes high. Okay, as I work backwards, I'm at the axis, low, axis, high. Okay, now every place I'm on the axis. Now notice the phase shift. My asymptotes will have a phase shift of that pi over 2 because that's the phase shift between sine and cosine. Okay, so now you can use that phase shift because whenever sine is 0, my cosecant has an asymptote. Okay, whenever sine is 0, my cosecant has an asymptote. And that makes sense, right? Because 1 divided by 0 just doesn't make, I can't find a value for it. Now, want to emphasize, my graph would look something like this. For my sine, my actual cosecant graph uses the highs and lows and then approaches the asymptotes on either side from those highs and lows. Okay, because we're doing the reciprocal of those, and I'm going to do those in black. I don't want to be crazy or spend more time on this than needed. If you have questions regarding them, please let me know. Okay, but that's what's happening with your cosecant graph. Straight up, you do everything like it's sine and you flip the graph. Okay, because it's reciprocal of what the value is. As it approaches 0, remember, it's going to tend to infinity. So that's why it flips your y value. Questions? Is it making sense? Can you see why we're doing this? Because you guys did all this sine cosine graphing. Now we got cosecant and secant. Both are still 2 pi. Their periods are 2 pi in general until we start monkeying around with them. We work with them exactly the same way we do with sine and cosine. We're going to see that we got 2 example problems coming up here. Okay. Questions regarding it all? Now, one of the things I found that was helpful is being able to graph this, the general one, on my own without even looking at my notes and getting that done. And then I can make the adjustments for the others. Okay. But you have asymptotes going across where the regular graph would cross to 0. Yeah.
So when we start doing like phase shifts and everything, would it be helpful to start to graph the sine and then
I would be looking at the sine and do exactly what you do with regular sine, cosine, with the phase shifts and all. You know, like do your axis, your horizontal axis, your vertical, you know, where it starts. And then from there, set up like you're going to do sine or cosine, depending on what the problem is. And then do the inverse of, you know, what's going on. Because that makes it, and I want to make sure that that's how I'm going to show the graph because it's faster. You guys are really good at sine and cosine, at least I'm hoping right now, and then the phase shifts behave the same, and then boom, everything else happens. But that's a great segue, but we're going to delay that segue for a second because I want to talk about these. Very similar to what we did with cosine, or I should say secant, because it's just that phase shift, the difference. So go ahead and look those over, get those down. Now step out of your way. Remember, the period for sine, cosine, secant, and cosecant, the length is from 0 to 2 pi until we start messing around with phase shift stuff. In tangent and cotangent, it's just 0 to pi. And we will be showing those tomorrow. It'll be on a different day. It'll be separate, and that's why I decided to do it the way I'm doing it today. I want to make sure it's clear that these are all 0 to 2 pi period lengths. There's a story with that. Grades will be updated tonight with the email as well. So just know that I will be struggling at home to get that done. Because I'm not saying that our internet's slow, but turtles have been known to pass it. Okay, just to let you know. Okay, questions regarding any of the information about vertical asymptote, horizontal asymptote, or anything? I could run through it, but you guys can read through. The big thing I want you to know, it's an odd function, remember, because sine is the key on this, and it behaves the same as sine. So if I have a negative b, that negative comes on the outside of the function, okay, when I'm working with it. So I will never have a negative b. I'll rewrite it so it won't be, okay? Now, let's look at a regular problem. See what's up, okay? I have a cosecant, okay? Cosecant is 1 over sine, right? We just worked on that. So I'm looking at 0.5, I have negative 0.5 cosecant 2x minus 1. Notice the negative came out because it's an odd function, okay? Now, that's the necessity of knowing the difference between odd and even. Bless you. So I've got A, the absolute value of A is 0.5. Okay, I will be flipping this function. I've got to kind of remind myself I got to flip it upside down because of the reflection of that negative 1. They want me to graph 2 cycles. I've got a B, it happens to be 2. My period for this function is 2 pi over B, which is just pi. So now I've got to look at splitting that pi up into 4 equal parts. And working on their separation, it's pi over 4. Okay, so I don't have a phase shift. I just have got a compression. I won't be changing the start. It'll start at 0 here. I should say it that way. I have a horizontal compression. Okay, it's half as big, it's half as long as my period is going on. So I'm going to be looking at my key points as 0, pi over 4, 2 pi or 2 pi over 4, or pi over 2 I should say, 2 pi over 4. I got 3 pi over 4 and pi. So those are my biggies I'm worried about. They want 2 full cycles. So I'm going to go every 2. I got pi over 4, pi over 2. I can actually write that in. 3 pi over 4, and I've got pi. If I want, I can go 5 pi over 4, and 6 pi over 4, which is going to be 3 pi over 2. I can go backwards with these. Negative pi over 4, negative pi over 2, negative 3 pi over 4, negative pi, negative 5 pi over 4, and negative 3 pi over 2. Are there any questions about what I'm doing in my setup? Everything's exactly the same as if I were working with sine. Okay, now keep in mind, I'm looking at this, I've got this going on, I've got to go down -1, so I've got an axis down here of -1 I'm working with. So y equal -1, okay, is my horizontal shift, excuse me, my vertical shift, not my horizontal, my vertical shift. I don't have a horizontal shift, I'm starting at 0, and I'm working with sine, so the first thing I'm thinking about is, okay, sine starts on the axis, and it's a half, but it's negative, so I flip it, so it's going to go down a half, it's going to go up, it's going to go up a half, it's going to go back to axis, down a half. Somebody did this a little fast together. There we go. It's going to go back to axis, down my half, back to axis. And I'll be flipping it back the other way, be coming up here, back to axis, down a half, back to axis, up a half, down a half. Excuse me, back to axis. Now, remember, that's my sine. Okay, I am not really working with sine here. I am working with cosecant, which is the 1 over sine. So, with that said, at my zeros, at my axis points, I should have asymptotes. And off my highs for my graph, those are my graphs coming off. So I have my A, I'm talking about it being a flip, okay, because it's reflection across the x-axis. And so everything is a little bit the reverse if it weren't. Questions? Let's do this. Put that away down there. Okay, are there any follow-up questions? Now, questions on why I moved that negative from the B to the front side to A. Remember, because it's an odd function, it comes from the inside of the argument to the outside, all right, because that's that effect of that reflection, okay? Sketch at least 2 cycles of the graph of the following equations. We got one left. I lied, wrong page, got to go down, okay? Now, this is secant. I will do everything with this that I would with cosine. Okay, I've got a phase funky in here, and this is a funkier phase than we're used to seeing. Okay, because your B is going to be like pi over 2. So let's talk about that as we're looking at this. So the first thing I'm looking at, I got 2 secant. I'm going to factor out that negative pi over 2 x. So if I factor out a negative pi over 2, that kind of means I had a negative 2 inside. Okay, because negative pi over 2 times negative 2 is pi. Okay, so I'm looking at this. I've got my A. Okay, my absolute value of A is 2. I'm looking at B. B happens to be, well, you know, because it's cosine, because it's even, B happens to be pi over 2 because with an even function, that negative right there is no longer needed. Okay, because it's an even function. And just to check, because you know I've talked about this before, and because this period is from 0 to 2 pi, just going to divide it out, and I'm here at 0. That's x minus 2. And I divide, and I find out that that's 4. And I'm going to add 2. So my values of this function was going to go from 2 to 4. Okay. Did you see how I took pi right out of the equation on this? No longer am I working with pi's over 2, pi's over 3's. I'm just working with regular numbers that are in radians. Okay. So I'm setting up my graph. I'm looking at, hey, this is going to be like 1, 2, 3, 4, 5, and 6. My actual graphs can go 2 to 6, and I can go back -1, -2, -3, -4, and I suppose -5 if I wanted to, -6, and I can get my work here out of the way so we know what's going on there. So now, keep in mind my period. Let's talk about my period. It's normally 2 pi. Pi over 2, it becomes 4. I divide that up into 4 equal parts. Ooh, it's 1. So my separation is 1 because I went 4 divided by 4. That's where I get my 1. So I should have my values I'm worried about starting at 2, 2, 3, 4, 5, and 6. Those are my 5 significant values I'm working with on this graph. Because I'm supposed to start at 2, I'm supposed to have a separation of 1 in between each one, and I go to 6. Okay? And remember, this is secant. That's 1 over cosine. I don't have it negative, so I'm going to graph it regular. But I start at 2, and I don't have a vertical component on this graph. Okay, so I'm not going to be worrying about pulling it off the x-axis. So I'm going to start right here. That's my starting spot, but it's cosine, so I start high. Cosine is supposed to be 2, so if that's 2, I started at high. I go to my axis, I go to my low, go back to my axis, and I go high. And I can reverse back 1, low, axis, high, axis, low, axis, high. Okay? Any questions on how I'm doing any of the sketching right now? I'm not going to put in my whole graph for cosine. I'm just going to put in from my highs my secant. Yeah, Grace. Why did I start at 2? You notice on this phase shift that it pulled me over, and we would expect that it would be pushing over to 2 units to the right. Okay, that would be my horizontal phase shift. And that helps me start with this. And that's why I do that. But another way of looking at it is when I add in that phase shift, because I know it's 2, and I do the division, and I've made the division wrong. You've seen it, okay? When I get to that step, when I'm double checking myself, just to make sure, because my calculator is incredibly hard to set these up to check, okay? It just makes sense for me to kind of build in some little personal checks for myself, checks and balances as we go through to make sure that's going to work, okay? Now, I've got 2, 3, 4, 5. Remember, every time I have a 0, I have an asymptote. So every time I'm on the axis, I have an asymptote, that axis of symmetry that I keep oscillating back and forth on. So I show those and make sure that they're there. Make sure that you're showing them. I'm looking for them on your quiz. I'm looking for them on your test whenever we have you do this. Okay, and then from my highs and lows, let's flip out the function. And that one's going to be up here. Let's go there. Are you okay with how I'm getting this graph completed? Yeah, no. Are we in between? It's very quiet. I've got some people with thumbs up, which is awesome, but I've got some people with that furrowed brow look. Remember, It's all, I'm defining this based on sine, cosine graphing. I promised you I would, and here it is today that we're doing it. Want to make sure that you're comfortable with that, and make sure you know that the asymptotes are set up when the sines and cosines are both 0, because the reciprocal of 0 doesn't exist. That's why there's asymptotes at those points. Okay, the highs and lows are the lows and suggested highs of your cosecant and secant, and that's where it extends out to. You know, when we're talking about your range, it goes from negative infinity to whatever that high of that cosine or sine was to, you know, the or low, and then it goes from the high up to infinity. So keep that in mind as we're working with this. There's connection with that, so it makes it easier for us to do our graphing work. Any follow-ups? Okay. Let's see where we're going here. That's tomorrow. One thing I want to do today is look at your tangent stuff, because I have been always referring to the fact, we're back on page 1 of this section. So if you go back to the start of 4.5, I think you got 3 pages back. So what's page 14? Page 14, I think it is. Or is it 12? Oh, good Lord, it's 12. Yeah. Okay. Go back to 12 for a second. I just finished graphing cosecant and secant, and they are based on sine and cosine graphs. They also have 0 to 2 pi periods. Okay. Tangent and cotangent are unique. They start repeating themselves every pi. Okay. Periods. And so you'll see a change when I'm working with phase shifts. I'm no longer going from 0 to 2 pi like I did with sine, cosine, secant, and cosecant. I will go 0 to pi for tangents and cotangents. I will still look for those 4 key figures, 4 key points, okay? But it's between 0 and pi. And here's why. When I'm looking at this, if I talk about negative pi over 2, okay, negative pi over 2, my tangent, as it approaches 0, as my, I've got, you know, sine over cosine, okay, well, pi over 2 and negative pi over 2, I deal with the sine and cosine as I'm working around my circle. And remember, I'm working around the circle. I've got 0, 1, and 0, negative 1. Well, if it's sine over cosine, as I approach 0 with my cosine value, it's going to go to infinity until it doesn't exist. So it's going to be incredibly close to pi over 2, but it will never cross pi over 2. Okay, so this is my negative pi over 2, and this is pi over 2 as I'm working with this. And remember, this is still 1 over 0, and this is still 0 as we're working through with this. Okay, when we're looking at our unit circle. If I'm going this way for negative pi over 2, that way for pi over 2. So this is the first branch of the graph that we always will talk about when we're working this out. So what I need you guys to know, somebody did put this in, but maybe that's why I wanted you guys to have this extra time. Negative pi over 2, okay, is negative 1 over 0, or DNE, okay? I want you to find the negative pi over 3, negative pi over 4, negative pi over 6 as we're looking these over. And you should be pretty decent with these as you go through. Once you get here, they should start repeating themselves, except there'd be a positive, you know, version of them. Okay, and just go ahead and find those right now. And we should know this from the unit circle. So take 2 minutes and fill those out. I'll stop this time on this. Okay, so if we got negative pi over 3, we're sitting negative pi over, I'm right here. Okay, so won't that be an x value of 1/2 and a y value of the square root of 3 over 2? But it's negative. So I've got 1/2 and the square root of 3 over 2, and that's a negative square root of 3 over 2. If I'm talking about that, negative square root of 3 over 2, because it's sine over cosine, the same as multiplying by that, would be negative square root of 3. All I'm doing is sine over cosine, okay, for tangent. Okay, now pi over 4, the negative pi over 4 I love to death. You know why? It's 1. But in this case, it's -1 because, let me get a different color, it's right here, and that's going to be -pi/4 is the square root of 2 over 2 and the negative square root of 2 over 2. Okay, so that's going to give me a -1 because they're the same number. Are we doing okay with that? Pi/6. Now, I have a negative and a positive version, you know, as I'm going on. I'm out here. If this is pi/6, I'm going to go up here. This is -pi/6 we're talking about. And to get out there, it's the square root of 3 over 2. But negative brings me down. So negative square root of 3 over 2 and -1/2. Okay, all from the unit circle. All, as I promised, would be coming to be important as we're going through this. Remember sine over cosine. So we're going to get, my sine is -1/2 times my cosine reciprocal 2 over the square root of 3. So that's -1 over the square root of 3, or the negative square root of square root of 3 over 3 when I'm working with that. Okay. Tangent of 0. Sine is 0, cosine is 1. It's just 0. Okay. Are there any questions about those values? Because you know what's going to change for the rest of them? There just isn't any negative values. Every one of these were negative. Pi/6 should be the square root of 3 over 3. Pi/4 should be +1. Pi/3 should be the square root of 3. And guess what? DNE. Okay? But it all tended from my unit circle. And my comfort level with it, depending on where I'm at. I guarantee it will not go away if you go on to calculus. It doesn't matter where you go on to calculus. You will have to know it. Okay? I promise. Questions about how I'm generating these values? Please keep in mind that that's what these points are as I'm working on my tangent. Okay? That is the graph of tangent. Principal branch from -pi/2 to pi/2. Feeling okay? Yes or no? Because it just repeats itself. That's all it does. Every pi, it does the same thing. Okay? Now, I think that's all I wanted to do today because we'll get this filled in and then we'll call it. So tomorrow will be easier. Come on. Really? Okay. We'll get those zeros done. So you guys can fill that out and we'll start out tomorrow right off the bat so we can not feel like it's too stressful. For those folks at home, keep in mind the notes for today was starting on day 2 first, and then we went back and caught a page of day 1 so we could actually finish day 1 tomorrow. So know that. I'm going to answer questions, I think, on the Ferris wheel problem next.